So, we have this projectile, okay? And a particle is fired from a point on a horizontal plane with initial velocity of 50I plus 46J meters per second, find its range. So lads, what we're looking at here is this. I have to do number 10 as well. So, what projectiles are is, you fire something in the air, and then it drops, it goes to a maximum height, and then it drops back down again. Now, what happens with this one is, you're firing it in it's travelling technically in two directions. It's going 50 across every second and 49 into the air every second. Now the problem is that the acceleration only acts directly downwards at 9.8. So you're going to use the formula phi equals u plus at, and we're going to find out what phi x and phi y are. Phi x has to stay the same because it undergoes no acceleration, because it's going directly to the right. There's no, gravity doesn't act left to right, it acts downwards, okay? So phi x stays as 50. Phi y, however, changes. It was 49, and now it's going to be minus gravity times time, because gravity is the acceleration working against it. Gravity being 9.8 t. Now, next thing after that is you're going to find out how much distance do you cover going left to right. So if you're in the air, floating at this point here, you technically have two distances you covered, or two displacements. Excuse me. Your displacement from where you began going left to right is Sx, okay, and your displacement going up to down is Sy. Second. So what you got to do is you got to construct two equations, one for Sx and one for Sy. So here we go. Okay, so what Sx is going to be, so remember S is ut plus a half at squared, so we're going to use that here, and what we're going to get is S is 50 times t, and because it has no acceleration in the x direction, it just stays as 50t. Sy is going to be ut, u is 49 in the y direction, and then it's going to be minus a half gt squared. Please remember g is 9.8, a half of 9.8 is minus 4.9 t squared. Every single time you do these questions, you more or less, you usually will use all five, or all four equations. Sometimes you won't.
Is it twice? G
is working against it, going downwards, okay? Now, find its range. Range refers to the distance you've travelled in this direction here. So remember what I was telling you earlier, when this ball or object is at this height, it has two displacements. It has an Sy displacement from up to down, and then it also has a Sx displacement, which would be from here to here. In this case, the Sy is 0 because it's at the range. So what you're looking to do is find out what is the distance. So Sy equals 0, then find out what the Sx distance is. So we put Sy equal to 0, then we bring over the, sure look, we can just factorize it here, no real hurry on that. So we'll just take out 4.9 t, that's into 10 minus t equals 0. Either 4.9 multiplied by t equals 0, or 10 minus t equals 0, t equals 10, or t equals 0. T is not equal to 0 because that's referring to when you took off, not when you landed 10 seconds later. So now you know that t equals 10 when this happens. You have to find out how much s of x distance did you cover in 10 seconds. So s of x is going to be 50 multiplied by 10. And what's that going to get us? 500. 500 meters. Is that right? Okay. This time around in question 10, what it does is it gives you that, it tells you at the very beginning 50 is thrown out in this direction here. Okay? Now, if I is along the horizontal and J is along the vertical and cos theta is 3/5, so this is theta, and what we're also looking at is a right angle triangle of 3/5. So that's theta, that's 3, that's 5. Pythagoras' theorem will tell you that's 4. And then we know that sine theta therefore has to be 4/5. Good, happy with that? Now, express the position vector R of the particle after t seconds in terms of I and j. Okay. So, the way we're going to do this is, this side here is technically the adjacent, isn't it? And this is the opposite. So, the way this works is, the long way around doing it is call that x and call that y. And also what you say is cos theta equals x over 50. X over 50 equals 3/5. X therefore equals 30. Sine theta equals what's it? Y over 50, which equals 4/5. Y technically equals 40. So saying this here is the same thing as me saying 40i plus 50j. Its velocity is 40i plus 50j, which makes it exactly the same as question 5. Okay? Now there's something else I want to run over, which is why we're here. It's what's called the general way of doing this.
Is it not 30i?
Oh, it is, sorry. 30i plus 40j, excuse me. You're right. 30i plus 40j. Now, there's a general way of doing this, right? Here's the general way of doing it. If I give you any speed whatsoever, we'll call it u. Automatically, and I call this cos alpha. Automatically, the I vector is u cos alpha. The j vector, u sine alpha. So this is basically a quicker way of doing the same thing. In this question, I had theta. So it should be u sine theta plus u sine theta I. Oh, sorry, cos theta. I'm going on the bottom. U cos theta I, u sine theta j. Now look what happens. What's the u value here, guys? U value is 50. So it's 50 times cos theta, which is 3/5 I. And then it's 50 times sine theta, which is 4/5j, and that will get you your 30i plus 40j. Works like that every time. Okay? Now once you've done that, and you know what your value is, you gotta go to your equations. Now, what I want specifically is the position vector. Now let me tell you what position vector means. Position vector means that if I have a particle and it flies up in the air and back down again, okay? At one point it's 40 meters in the air and it's travelled, 70 meters relative to the ground. What's the position vector then? 70i plus 40j. Okay? It's basically Sx times I plus Sy times j. That's a position vector. So, in order to sort out the position vectors here, what we do is we're going to do the ut plus a half at squared. Okay? So, I like to go through all four of them. I always tend to go through all four of them anyway. Px equals 30. It will always stay as 30. Py equals 40 minus gt, or minus 4.9 t, minus 9.8 t. because it has the deceleration of gravity. Sx is ut plus a half at squared, which is going to be 30t plus nothing because there's no acceleration in the a direction. And then sy is going to be 40t for ut, and then it's going to be minus a half at squared. So it's going to be plus a half at squared, but because a is minus gravity, it's going to be minus 4.9t squared, because minus half of gravity is 4.9t squared. So now my position vector and my answer to part 1 is this. R equals 30t times I plus 40t minus 4.9t squared times j. What does that mean with the t? The t means every second your position vector changes. So if I put in t equals 1, I'll get 30, and it'll be 40 minus 4.9, which will get me, it'll be 30i plus, what's 40 minus 4.9? 35.1j. So it means after 1 second, I'm located 30 meters away from along the ground, and I'm 35.1 meters in the air. That's how that formula works. Now, find the magnitude to the nearest meter per second and the direction to the nearest degree of the velocity of the particle when t equals 1 second. Okay, what do you mean by the velocity of the particle?
The hypotenuse of the triangle.
The hypotenuse of the triangle, basically, right? So, after 1 second, phi x is still 30, and phi y is 40 minus 9.8 times 1. This results in a velocity of 30i plus 30.2 j.
Sir,
Yeah?
how did you minus t squared from t?
Huh?
40t squared minus 4.9 t squared.
For which one?
For the j value.
T
This here?
value of
Yeah, it's t and t
40t
squared.
minus 4.9t squared.
I actually didn't do that. I just put in t equals 1. I didn't actually take them away. I was just saying, as an example, after 1 second you would be this far. You can't take them away because you can't take t squared away from t. I just put in t equals 1, and I was just showing you that after 1 second its displacement was 30 across and 35.1 into the air.
Yeah, okay.
So you're on your way up here, 30 across and 35.1 meters into the air. Okay, so that's what we have here is 30.2. I have to find out 2 things. It's currently still on its way up, and we have to find the hypotenuse. So if somebody will get me the hypotenuse of that, that'd be great. If a second person will tan inverse 30.2 by 30, that'd be good as well. You're on tan inverse.
Yeah,
you're on hypotenuse.
30/2
What is it?
for the
Hypotenuse. 30. Shh. That's 30/2 for the hypotenuse, and the angle 45.19. Okay. Shh. It's currently going up at 45.19 degrees, and it's going 30/2. Lads, how do you calculate the horizontal range? Can anyone tell me the combination for horizontal range? So lads, come on, horizontal range. So we tell me the combination to find out what the horizontal range is. It has everything to do with the 4 formulas I have here. So what does horizontal range mean again?
That's phi y is 0.
Sorry?
It's how far across the gate is that.
Okay, so here to here, which means you're using the fx equation once you find out what the time is. How do you find out what the time is?
Phi y, let phi y equals 0.
Okay, there's 2 ways of doing it. You're currently describing phi y equals 0, which is the maximum, which is at the maximum height. And you double it, because the time it takes to go up equals the time it takes to go all the way back down again. That's
Would that not be bottom, and then you get 2 values?
sy equals 0.
Oh,
So Vy equals 0 is when your velocity is no longer going upwards and you stop for a second in midair and then you're on your way back down. We can double that time, or we can get Sy equals 0. I'm going to show you that they're both the same thing. Vy equals 0 is basically 40 minus 9.8t equals 0. T therefore equals 40 divided by 9.8. I don't know if that is in the calculator, so we just put that. What?
4.08.
4.08.
4.08.
I beat you. 0.2.
Okay, lads. So it's 40.08. Oh, sorry.
4.08.
Thank you. Now, the other one, and we have to multiply that by 2 to get 8.16, because 8.16 is double that time. Because the 4.08 was your time taken to reach the top. Now, if we did Sy equals 0, and what we do there is we get 40t minus 4.9t squared equals 0. Take out t, and you get 40 minus 4.9t equals 0. Then you get t equals 0, which you don't want, because that is referring to this point here. Or we're going to get we're going to get 40 minus 4.9t equals 0, and that will come out as t equals 8.16. Both the same answer.
So that means it's traveled like to get to like hit the ground again in 6 seconds.
Yes.
Okay.
And then you're going to insert that into the SX formula, which is going to be 30 multiplied by 8.16, and what do we get?
45.
200 and? 244 points?
89. Oh, 245.
Yeah, 245, okay. Alright, that's number 10. These are orderly levels at the moment. Okay? Now, next one is a higher level. Flat higher level. Flat higher level is usually going to be a part A. Okay, and use your time with target practice if it's a part A. Now, so question 12 is a good one to start off on. We can find it. There we are. Let's keep it on. Now, this one here is, it gives you nothing concrete to work with at the start. Lads, you're going to stop talking. Please distract me. Alright. So that's what we have here is there's a general form at the start. Remember I said earlier, if you throw up a U and it's an angle alpha, it's going to be U cos alpha on the bottom, U sine alpha for the J value. You happy enough with that? It's the way it always works. Okay? Now, once you do that, you're going to put in your phi x formula. Phi equals U plus AT. So phi x therefore is going to be your I component, which is U cos alpha, because that's your initial velocity along the x-axis. It has no acceleration, so it just stays the same way. Phi y is, and we take a guess.
And you still use alpha
Minus gt. Yep, so stop there. S of x. So you're talking about s equals ut plus a half at squared. U is U cos alpha. Or ut cos alpha, because I won't say U cos alpha t. I'll put the variables together. So ut cos alpha, is that okay? And then no acceleration, because it's along the x-axis. Sy is ut sine alpha minus a half gt squared. You happy enough with that? Now, it talks directly about the greatest height reached. Okay? So, when you're talking about the greatest height, what type of distance is the greatest height? Is it an SX or an SY? Huh? It's an SY. When you're talking about the greatest height reached, you're talking about this distance here in the middle, and it's an SY. Is there anything else? So that's one of the equations, you know you got to use SY, which is grand. We need one of the other equations to tell us what the time is. Any idea which equation we could use? Vy equals 0. At your greatest height, your Vy stops and is equal to 0. So you go to Vy equals 0, and what you say is that u sine alpha minus gt equals 0. You need to isolate t. Move the gt over the other side, you get u sine alpha equals gt. T therefore equals u sine alpha all over g. Okay? Everybody happy with that? That's a general formula. Do you know that? If I give you any numbers for any one of these, if I give you a value for alpha, if I give you a value for the u value, you can calculate what it is. This formula always stays the same. What I can do is I can say, oh look, that's all of a sudden this is beta. And instead of speed u, I'm going to give you speed 2u. And in case like that, you change that u to 2u, and you change the alpha to a beta. Okay? Bottom line is I don't have any of these learned off. I know how to make them every time. I make them fresh every time. Okay? So, what we do here is we get the sy and we plug it in. So we get sy equals u multiplied by u sine alpha over g minus, now this is like gt squared all over 2. So what I'm going to do is g on the outside and 2 on the bottom, g over 2. I'm going to put t squared in here. T squared is going to be u squared sine squared alpha over g squared. Now what happens next, guys? G cancels with g, and what you're going to be left with is u squared. Oh, there's one other thing I forgot. Do you remember we're replacing t, aren't we? There was another sine alpha here that I didn't put in, and that happened to you quite a bit. So it's u squared sine squared alpha over g minus u squared sine squared alpha over 2g. Now, if you look at them, they're pretty much the same thing. U squared sine squared alpha, u squared sine squared alpha. It's a full object minus a half of that object. Everything's the same bar the 2. So it's an object, it's like a cake. Take away half a cake, and the yellow stuff's the cake. Alright? So what you're left with is half a cake. So you're left with this answer here. U squared sine squared alpha all over 2g. You could get them the same denominator, put 2 there and put 2 there. Then you have 2 of them, take away 1 of them, which is 1 of them, all divided by 2g. Okay, now the next thing they want us to go after is the range. What's the combination for the range? Combo for the range. Anybody know? Combination for the range. So the range is down here. At the bottom. Sorry? It's an Sx equation, which is grand. So there's Sx right there. Okay, and what's the other one? What happens when it hits the ground?
The x is 0.
The x is?
The x is 0.
The sy is 0. But we also had a bit of old work done a minute ago, didn't we? We already worked out what we already worked out what Vy equals 0 was, didn't we? So we actually should have just started that and just multiplied it by 2. It would be a lot easier. So there's always 2 ways to do this. To get the time, you can either do sy equals 0 and then find t, or you could do Vy equals 0, find t, and then multiply by 2. Because it takes half the time to get up there, then the same amount of time back down again. So we already did, this one's easier because it's not a quadratic equation, so it would have been t equals u sine alpha all over g. Multiply that by 2 for the full range, and what you're going to get is t equals 2u sine alpha all over g. Next thing we're going to do is plug that into the SX equation, because range is a SX equation. Okay? So what we get is SX equals U multiplied by T, which is 2U sine alpha all over G, multiplied by cos alpha. And what we get here is 2U squared sine alpha cos alpha all over G, which is what we're looking to show. Okay? Now finally, if U equals 70 and the greatest height is 125, find the value of A and hence find the range. In this question, we're lucky enough that they give us the two equations to use to begin with. So what we can do is we can use the work we've already done to answer this question. So what I suggest we do is this. U is 70, find the greatest height. Fair enough. I'm just going to use this equation right here. So I'm just going to get 70 squared sine squared alpha all over 2 times 9.8 equals 125. I'll put all of this part into my calculator, and whatever that answer is, I'm going to divide it down here underneath the 125. Okay, so if somebody will...
It's 250.
Is it 250?
Yeah.
Andy, what's it divided by 2 times 9.8? 250, I have in scientific notation. So 125 divided by 250, a half. So sine squared alpha is equal to a half. What does that mean about sine alpha? What? No, it actually doesn't work. It's like is equals to square root of 1 over 2, which is root 1 over root 2, which is 1 over root 2. So you're going to sine inverse. Do you remember sine inverse? To get an angle. So alpha equals sine inverse 1 over root 2, and that is a 45-degree angle, because that's 45 degrees. Now, we know that it's 45 degrees. Oh, that's the question, isn't it? Well, sorry, I have to find the range then. So, I know it's 45 degrees. So, to find the range, just use the range formula. 2 times 70 squared sine 45 cos 45 all over 9.8, and that'll tell me how far I've travelled across. Anybody know? Who's got it? Who's got the... It's 4,900 divided by 9.8. 500. Okay, so it's 500 meters. To do question 14 in a test, we would repeat 12 part 1 and 12 part 2 exactly the same way as done before. We would assume that we threw up the ball at a speed u and at an angle of our choosing. Let's call it alpha. By going through the same method as 12 part 1, 12 part 2, we find out that the height, what's the height in 12 part 2 again? It says it in your book. What's the maximum height? 2u squared.
U squared.
Is it u squared?
Yes.
Not 2u squared.
U squared sine squared.
So u squared sine squared? Alpha and underneath that? 2g. And what's the range?
2u squared sine alpha cos alpha.
All over?
G.
G. Now, key words. The maximum height is double the range. So you're really talking about a big steep angle, almost like a box kick in rugby, where you're basically Making it applicable. Alright, so basically it goes really high and it comes back down again. So you're talking that your height is much bigger than your than how far it's going. Okay? So in a case like this, we're going to say that H equals 2R. So what we do is we put a 2 here. So it turns out to be 4u squared. And now we put both formulas equal to each other. So we're going to say that u squared sine squared alpha equals 4u squared all over 2g. Is that 2g on the bottom?
Yeah.
2g?
Yeah.
4u squared sine alpha cos alpha only over g, right? Not 2g, g. Now, looking at the two of these, I'll have to put another 2 on the bottom. Put a 2 on top. 2 multiplied by 4 gives me 8. Now we start crossing off stuff. U squared cancels with u squared. 2g cancels with 2g. What I'm left with is this formula here. I'm left with sine squared alpha equals 8 sine alpha cos alpha. So sine squared alpha basically means sine alpha multiplied by sine alpha. So sine alpha multiplied by sine alpha equals 8 sine alpha cos alpha. Sine alphas cancel. Cos alpha divided by sine alpha. So 8 equals sine alpha divided by cos alpha. If you look this up in your tables and you're soon to know a lot about this, sine alpha divided by cos alpha is always tan alpha. Tan alpha equals 8. We know tan alpha is opposite over adjacent. This means your box kick is going up 8 meters for every 1 meter it goes across. You're literally kicking it straight up into the air, so it's only with a slight bit of distance, okay? You tan inverse that angle to find out what angle does it actually go up. Tan inverse 8, and what you get when you tan inverse 8?
82.87.
82.87. Okay guys, that's your angle there. Alright, we're done.